environment. The Lorentz forces are
Don't.
yeah, because I know the magnetic field doesn't have that capability, but it's the Lorentz force does, and the acceleration it's growing and growing and growing, and then it's well, once it's escaped into the interplanetary magnetic field, or once it's escaped Jupiter, then it's in the solar wind and the magnetic field of the sun. Then it's subject to different forces out there, but it already has a speed that's moving, escape velocity out of the solar system even. Some of these Jupiter dust stream particles can escape the solar system because they're moving so fast. And so the collective properties, that's an area of dusty plasma physics. So if you have a high enough density of dust, you start having the dust behave in a collective way so that instead of needing to carry individual motions, now you have a group, a slab, and they have higher induced properties because it's moving collectively that way. I want to learn more about dusty plasma physics, but I don't know enough yet. But that's a pretty active field of research, and there's a lot of papers, to study these collective effects. So there's acoustic wave motions, for example, that look like ocean waves, but it's what happens when you have high density dust in a strong magnetic field that's behaving this way. So there are collective effects. I don't know if that explained it.
If I may add, just visually you have those filament structure in the tail of the comet, but would that be some kind of collective organization or ripples?
I think
smaller than
I think that's more related to the fact that the magnetic field will act as a mass spectrometer to separate the sizes of particles, and because some will be moving faster and they're a certain size, and so they'll start to separate out due to the behavior, due to their intrinsic characteristics of size. So.
And going a little bit back to the question of Professor Zeber, so if I got it correctly, so there are at least three actors. One is this dust particle, then the magnetic field. There's also the plasma,
exactly.
which would carry the field with it, and that would transfer some mechanical momentum to
Right. In fact, one area of emphasis that my advisor Eberhard Brun has been trying to promote in all of his talks now is the idea of having a dust telescope as the equivalent of an optical telescope, because if you know the plasma really well, if you know the magnetic field really well, and if you know the intrinsic properties of the particle, then you can model that particle and trace it backward in time. So if you collect that particle here, and you know the intervening magnetic field and plasma, then you know where that particle came from.
So in a sense, like you saw Io, right? So that was kind of the first picture of a dust telescope.
Right.
Thank you. More questions, please, or comments? Tired.
They're smiling. That's
yes, that's a very good sign. Absolutely, and I think everyone has really enjoyed your talk. So let's thank Amara once again. And, please make sure you sign up on the sheet or some registration sheet going around.